Hi, everyone. My name is Jamie Harbin, and I work at Dalhousie University.
Hi, I'm Dan Kelly, and I also work at Dalhousie University.
So today is our sixth video for our new package, argoFloats. And today what we're going to show everybody is how to do a trajectory plot of a specific argo. And then we are going to color code it by time. And this specific argo is just off of the Bahamas. So I'll give it to you there, Dan.
Okay, good. And I'm going to show people our studio. It's just one of many ways that you can run R. So the first task will be bring up the package. And we're going to use the built-in data set. Well, it's a bit slow. Okay, so we'll do data index. So we have a bunch of built-in data sets. This one will be fine. In normal work, what you would do is you would run the function called getIndex. We've talked about that before. Maybe what I'll do first is I'll just plot this just to show you. And which, you don't have to say this because it's the default, but which is map. And actually, I'm going to use bathymetry. Bathymetry is water depth. And this is a new feature, which, okay, this is a big tease. We're not going to show you in this one. We're going to show you in another one. I'm turning off the bathymetry right now.
Stay tuned.
Stay tuned. Keep sending in your dollars of support. Anyway, so here you see the argoFloats, and this built-in data set is in a circle around a little island in the Bahamas. And so there's a whole bunch of points there, and this is all the Argo profiles that have ever been made within this circle. And it doesn't mean that there are that many argoFloats in any given day or week or month or year or anything like that. And what we want to do is we want to show one of these floats. We want to show how to get the trajectories of one of these floats. So to do that, what you can do is, let me just see, God, why am I forgetting on this? So what we'll do is we'll get the IDs of these floats, and you get that by doing ID. I should call that ID. What should I call it, Jamie? Lower or uppercase?
I think we do upper.
Okay, we'll do uppercase. And why is that not working, James?
I think ID, the square bracket is also upper.
See, this is what's good about collaboration. So okay, so those are all the IDs, and I'll just show them to you. There's a whole whack of them. There just looks like there's 1,000 or whatever. I don't know what that number is. Now I could find the unique IDs this way. So there's fewer. It looks like there's 62 of them. Anyway, that's that. And then I could get the profiles for these guys, and that's index. These are profile numbers. Like the first time it goes up and down, that's 1, and then it's 2. And then it's 3, and and like that. Just changing my windows a bit here. Okay, so now what should I do? I think what I'd like to do, I have to make a choice as to which one of these mini profiles to show. And it seems to me it might be fun to just pick the one that has the most, the float, which has the most number of profiles. That's the one that more or less stayed here the longest. And bear in mind, these profiles are made about every 10 days. So a way to do that then is to do a table. And this is a fantastic function in R. One of the great reasons we use R for this package is there's so many built-in functions that do so many cool things. So this is a table of IDs. And the format that you'll see, this is the ID number. It's actually a character string. And there were 9 profiles for that float ID. And 2 for this and so forth. So one of these is the highest number. I don't know, is it this one? I have to look through them all. And that's sort of not very interesting. So one thing you can do is you can sort them. And this tells us, oh, and by the way, that was, I'll just do question mark sort, and you'll see the help on it. And there's an argument called decreasing. So I'm going to use the same thing, and the default for that is false. So what I'm going to say is true. Okay, so when I do that, the first entry, float number 490, I won't bother writing it out. That has 119 profiles. So I think that's the one we should pick. And let's see, so now what I'll do is I'll get the first element for that, and you can see that it's that guy. But I want its ID, so I'll call that ID 0 maybe. And I'll do names like that. So now what we've done is we've isolated, we found, just using our tools, nothing to do with our package, we found the float that has the highest incidence of profiles in there. So it was there for the longest, basically. So let's subset for that, and I'll call it index 0. I guess because we're calling this float 0. That's a funny name, but anyway. And we'll say ID is ID 0. So what we're doing, we have many different subset functions built into this package. You can subset by, well, we've talked about some of them before, but this way we're showing subset by ID. So it kept 119 of those profiles. So you can see there's 119 here. So that makes sense. Now let's see, what should we do next? Let's perhaps do this. Let's say that, let's have a look at the index 0, the date perhaps. So these are the dates for these data. So it looks like this float was running around in this region between the year near the end of the year 2011, and basically stopped, it left the region in the year 2013. So this has made 100 profiles in that time. So that's fine. We can find the profile numbers if we want. I'll just do that. And we see from this that in the region, we've got profiles 118, 119, and so forth. These look to me to be in order, but I'm not exactly sure that that's the case. So what I'm going to do is I'm going to say, again, this is just using a basic R function. I'm going to find the order of those, just in case they're not in order. I just don't know that in this repository whether they would always be in order or not. We do that. Now what O is, we can have a look at O. And I can actually do this. Okay, they're all ones, so they were in order, so that was sort of a waste of time. I still think it's a thing worth doing. So now what I want to do is I want to order by the profile number, and I want to get, let's say, the longitudes. So we'll do this. So far I'm getting all the longitudes, and I'll put O to put them in order, but again, they're already in order. We'll get the latitudes like this, perhaps. And maybe we'll get the time, T maybe, time or date or something. Not sure, but I'll put date.
It's date, yeah.
We should probably make it do time as well, but okay, maybe we'll just have a look at this head. Just for fun, we'll make a data frame. Yeah, so these are the sort of data. And there are lots of things we could do now and just worry in our tools. So of course we could plot latitude versus longitude. One of the problems with doing that though is it will auto scale and it might not make any sense. So what you should really do is set the aspect ratio as is appropriate for the mean latitude here. And that's done automatically by the plot method that's built into our package. And the package also will show you the land that's nearby. So what I'm going to do now is hand this over to Jamie. I'll stop sharing, and she's going to continue with more in this line of thinking.
Okay, so I'm going to share my RStudio. And essentially right now I have everything set up to where Dan has just left off. So he has pulled for the lawn, the lat, the time, and then in my case as well, I've just done the profile as well. So now what I'm going to focus on is just plotting that. So a lot of what Dan did, aside from the subsetting by index, that is part of our package, but the rest of it was really just basic R tools, which is really why we did want to create this package for R. But now what I'm going to show you is a lot of our package. So right now what I'm going to do is just create a color map. And if you're not familiar with color map, you can always do question mark color map. And essentially all we're doing is we're color coding these profiles by time. So as you can see by T, and we're just using this, this color scheme. So OCE colors jet. So you'll see what that looks like. So I will run that line. And then here, so line 17, all I'm doing is just setting the margins here. So now draw palettes, we've actually explained this in our last video, so I won't go too much into detail, but essentially I'm just telling it what colors to use and what format I want the time to be in. And then here's just setting the position. So I'm just saying that I want it on the right-hand side.
Can I interrupt Jamie for a sec?
Yeah, sure, go ahead.
So in the format, the percent capital Y, that means the year written with 4 digits. And then the percent lowercase m means the month. And these formats are part of, they're used in all formatting for time strings in R. And you can give the month by name, long name, short name. You can give the year without the 2000 or the 19 and whatever it happens to be. And you can give minutes and seconds and things as well. This is appropriate here. So it's going to be 4 digits for the year dash and then digits for the month. So thanks, Jamie.
Yeah, thanks for that. See, even I learn things while I do these videos. So we'll make that happen. And then, so here all we're doing is our basic plot function. So again, it is which equals map, but that's by default. And again, bathymetry equals false. And that's just kind of for a cliffhanger for our next video. So all I'm doing here is just subsetting for that one specific Argo float here. So now what we want to do is we want to do points.
Can I just interrupt again?
Yep, go ahead.
So again, what people see here is that it's giving the longitude and latitude, and it's being scaled. And the tan color, I guess, these are the islands that are nearby. And the scaling is such that the shape of the island should be correct to the actual shape. It's done a local scaling of a local aspect ratio of Y and X. Thanks.
Okay, perfect, thank you. So now what we want to do is we do want to, as I mentioned, we want to color code by time. So essentially what we're just going to do is, a lot of this is just kind of aesthetic things. So choosing the type of points that we want to use, but really right here is kind of where I'll say the magic happens, and that we're color coding by time. So you'll see what I mean by that when I make that happen. So there we go. And then this next line, all we're doing here, it's really just showing you where our point of interest is. So where we're setting our point on the Bahamas. So I'll show you what I mean by that. It'll just be a little, there we go, just a little star, just to say, okay, this is kind of where we're interested in. And then all we're gonna do here in line 22 is just connect the lines of the profile so we can kind of follow the trajectory. So again, as you can see here, the oldest is kind of the dark blue. So you can see that it really starts up here and moves its way along. So here what we're doing, make sure that I can describe this one correctly, but essentially what we're doing is getting it to show us the numbers of every 10th Argo float. So did I explain that correctly, Dan?
Yes, the profile numbers.
Yeah, exactly. So you won't see anything happening here, but where this happens is when I run this next line, we're going to show the profile numbers. They'll pop up on the map. And basically it's, as I mentioned, for every 10th profile. So as, again, you can see the trajectory was kind of along this path here. And then all we're doing here is really just letting everybody know what float number it was. And that was just the one that Dan subset of 4 that had the most number of profiles. So I think that's everything. Is there anything that you wanted to clarify on your end, Dan?
Not about the code, but I did want to point out about the data that it's pretty interesting that this float, it sort of meanders around for quite a while outside this region where these islands are. And then for whatever reason, you know, chooses to go in there. And then it gets into this little region in between the islands there. It spends a lot of time, I'd say almost ricocheting back and forth, circulating around in there until finally it escapes. And you'll learn more about why this happens. Uh, our friendly viewers will learn more about that when we put the bathymetry on here. But one thing I'd like to say, just as a physical oceanography prof, this really makes a diagram like this, and this is a passive tracer, it just moves along, it's showing the currents at about a kilometer depth, basically. It really shows you that the idea of a mean current is a bit problematic. I mean, if there were a mean current, these things would be sort of along a line or a curve going somewhere. Um, and this is a really an important thing for people coming into oceanography who have seen, I'll say, National Geographic atlases, which show an ocean with a little line showing this is where the current is. Maybe there are some places in the ocean where you could say there's a defined current at all times, but even there, if you put a current meter in, you'd see it goes one direction for a while and another direction for another while. And away from those really strong currents, near topography like this, it's pretty common to have, pretty meandering motion. It's really not about the package, but it's just an interesting thing that you can see by looking at these data. And a theme that we'll have in the upcoming videos probably will be just highlighting some of the interesting features that you can see in Argo data, and again showing you how it's pretty easy really to get to do analysis with this package, partly by leveraging the great power of the R system. And again, this code is online, and we always put all the code online. So that's it from me, Dan Kelly.
And I'm Jamie Harbin. Thank you for listening.
Thanks. Bye-bye.